Okay, right, so what we're doing now, we're going on to question 2. Using the method in question 1, find sine of BAC when AD is equal to 1. So we're actually changing the situation here. In fact, let me just draw it from scratch. We're changing the situation to when AD is equal to 1, and then presumably nothing else changes. So that's 1, 1. A, B, C, D. So it says using the method in question 1. So we're going to go through exactly the same process. Okay, exactly the same process. We're going to find AB, which is going to be 2 squared plus 1 squared square root. It's going to be root 5. Okay. We're going to find AC, which is going to be 1 squared plus 1 squared square root. That's going to be root 2. Okay. So we're going to find the sine of, I'll call that theta and that alpha. Why not? Just find it a little bit easier to use that notation. So sine of theta, I can just use right-angled triangle, is going to be 1 over root 5. And so now sine of alpha over 1 is equal to sine of theta over root 2. Sine alpha equals sine theta, which is 1 over root 5, divided by root 2. So sine of alpha equals 1 over root 5 times 1 over root 2 equals 1 over root 10. So I've followed the instructions perfectly. I've just gone through exactly the same steps I went through in question 1. Okay, the question told you to do that. So don't think that anything is any different, okay? I'm just asking you to follow the same steps. All I've done is where it said BAC, I just replaced that with alpha. And where it said ABD, I've replaced that with theta. Just because I like that notation. You could use a different notation, not a problem. Okay? Right, so question 3. Now we're getting a little bit trickier, but it's no different. Okay? What the skills we've just done, the process we've just taken, is going to be exactly the same for this question. So model sine BAC by letting AD equal x meters. So, and again, we are shown the answer. Show that this is the answer. Show that this is the answer. So you've already got the answer. So if you can't get to this point, you can still use this model in the next parts of the question. But should be pretty easy. Remember what we did first. We found AB. AB squared is going to be equal to this 2 squared plus x squared. AD squared is going to be x squared plus 4. AD equals the square root of x squared plus 4. Maybe you can see where this is going. So this is root x, sorry, not that one. It's AB. AB is the square root of x squared plus 4. Okay, now we needed to find this angle here. So the sine, which I call theta, you can call it anything you like. Sine theta is equal to opposite, so that's x over hypotenuse, that's square root of x squared plus 4. Nothing is changing. All we've got is just x's instead of numbers, okay? Then we needed to find AC, so we're going through exactly the same process. AC is going to be, let's go, AC squared is equal to x squared plus 1 squared. So AC equals the square root of x squared plus 1. Okay, now you should really see how this is all coming together. Okay, and now we use the sine rule. And we say that sine of alpha, which is what I've chosen to call it, you could just still call it BAC, doesn't matter, is equal to, sine alpha over 1 is equal to sine theta over the square root of x squared plus 1. Nothing is changing from what we did before. Can't stress that enough. Okay, so sine alpha equals sine theta, which is x over the square root of x squared plus 4 over, x squared plus 1 over the square root of x squared plus 4. It's just like before. We need to know how to do either using the flipping easy method. So that will become x over x squared plus 1, x squared plus 4. Okay? So basically in all modelling questions, they'll start off by giving you a question where you have to just do a process using numbers. Okay? They will then gradually introduce a variable. But nothing changes just because you put a variable in there. You still do the same process that you did before when there were numbers. So many students can do it when there's a number there. As soon as there's x's and y's and whatever in there, they think they can't do it. But it's the same process, okay? I can't stress that it's quite easy, actually, if you think about it in those terms, because part one of the question is just telling you what to do, okay? So I've managed to show that that is the answer. Okay. Right, now you're going to use your graphic calculator. So here is an easy question, which you can do even if you couldn't do part 3 because you were told the answer. Okay, so you're going to put that into your graphic calculator. Just bear with me a second whilst I do that. So we're going to say y equals x divided by the square root of x squared plus 1. Let's put that in brackets. And then x squared plus 4. Okay. And we can see that it's looking something like this. Okay, if you use your graphic calculator carefully. Okay? And once you've got that, which is very easy to do because, as I say, even if you had no idea what you were doing in this question, you were still told the answer. So there's an easy mark to get plotting that. And then there's another easy mark to get to find the value of x, which makes sine BAC a maximum. So use your calculator to find the maximum. Well, that value of x is 1.414. Okay. Find the largest angle of view. Well, that's the y value at that point, which is 0.3. Oh, hang on. It's not because I've got my settings wrong. I've got it in radians when I think it should be in degrees. So let me change that. Step 90 degrees. Hang on, 0, and we should be going 0 to 8. Actually, I think I've still got the right answer. Possibly. 0.33333 recurring. So the largest angle of view is 0.3 recurring. Okay? Not sure I've got that right, actually. If you think I've got that wrong, let me know. But anyway, you're just going to use your graphic of course, yes, I have got that right because that is what sine of BAC is. Sorry, that's what we should have said. Sine of BAC is equal to 0.333. So the largest angle of BAC is equal to the inverse sine of that. I knew something didn't feel right. Okay, so use your calculator then to find what that largest angle is. Shift sine of 0.3333333 Okay, and we get about 19.5 degrees to 1 decimal place. Okay, so again, I hope that makes sense, because remember what you're plotting is you're plotting sine BAC over x over the square root of x squared plus 1 times x squared plus 4. So when you plug in this value of x, you get sine BAC equals 0.3 recurring. And so BAC is the inverse of that. Hope that made sense, because I didn't spot that instantly myself. Okay, it's easily done. It's easy to